second presenter is Professor Christoph Schmueser. Online. Professor Schmueser is a student in the Fraunhofer Institute for Manufacturing Technologies and Advanced Materials. Go ahead, sir. Do you hear me?
I can hear you, yeah.
Okay, sir.
Hello.
Go ahead. You have 10 minutes, please.
Okay. Thank you for your interest. I will try to share my screen. I hope you can see. Can you see my presentation?
Yes, we see it clearly. Go ahead, please. Your time will start.
Okay. Yeah. Thank you for your introduction. Yeah. Hello, ladies and gentlemen, from my side. My name is Christoph Schmueser, and I work as an engineer at Fraunhofer Institute for Manufacturing Technology and Advanced Materials in Bremen, Germany. Yeah, together with my colleague, Dr. Ralf Wilken, on the EFAM side, the Fraunhofer side, and Professor Marwa Shalabi on the NRC side, I'm working on the project Sweetwater. Yeah, the motivation of this project is investigations on long-term stable hydrophilic anti-fouling coatings on RO membranes based on vacuum UV treatment. Yeah, in this picture, the procedures of the different treatment processes are exemplarily shown. On the left side, the first treatment type of the membrane is shown. Here, the surface treatment with VOV radiation is used to make the membrane surface more hydrophilic. Another treatment method is in the first step, again, a surface activation of the membrane, and then liquid precursors are deposited by aerosol on the surface and cross-linked, like we see in this right picture. And also modified and fixed on the membrane. In aerosol application, the liquid is atomized with compressed air in the aerosol generator and can then be directed as fine droplets onto the membrane surface. If the surface have been previously well activated, the droplets wet well and distribute homogeneously over the entire surface. A further VOV radiation then leads to a modification of this layer with the precursor we use, which should then be exhibit the desired hydrophilic properties. In addition, the irradiation should fix the layer on the membrane. Yeah, here our work plan in this project. We use this reverse osmosis membranes from the NRC on laboratory scale at the first time. In our work plan, we have a variation of the VOV treatment parameters for surface activation. It includes the distance substrate, the lamp module, the treatment speed, the lamp intensity, and the variation of gas atmosphere, especially oxygen content. The VOV coating, I explain what it is later. The VOV coating of the membranes, aerosol application of silicon oxide-based coatings or polyethylene glycols, and the variation of for the above process parameters. And then when we do it in lab scale, we transfer it to a VOV process to a roll-to-roll process. On this slide, I will give you a short introduction about the excimer how the excimer lamp works. An excimer lamp looks like an ordinary fluorescent tube, which are mounted on the ceiling. You can also connect them to house sockets with electronic ballast. Inside this quartz cylinder, there is xenon gas, which is ionized by applying a voltage between an inner and outer electrode, emitting electromagnetic radiation in the VOV range at 172 nanometers. This radiation is only one emitted from the transparent plasma reactor. Here's a little, we can see the background after the VOV activation. The first mechanism is an oxidation. The VOV radiation and the ambient oxygen form a zone and excited oxygen. These can interact with the surface and activate it, maybe. The second mechanism is photolysis. Here the radiation reacts directly with the surface and can create reactive anchors for other molecules. This radiation can also penetrate further into the material. And as a third mechanism, there's a combination of oxidation and photolysis. The most important process parameter in this treatment is the irradiation dose. We can adjust this by the power, the exposure time, the distance between lamps and our samples, and the oxygen concentration in our reactor. Yeah. Here's on this slide you can see our activation and coating plant. Results which we are previously determined on smaller test samples are now scaled up here. On the left,
3 minutes.
Yeah.
3 minutes to finish.
A question?
3 minutes to finish your presentation.
You have 3 minutes.
You have 3 minutes to finish your presentation.
I can. Sorry.
Professor, you have a minute, 3 minutes up to 30. Yeah?
I cannot understand you.
Please, Christoph.
Sorry, Professor. You still have 3 minutes to finish your talk.
Okay, I'm over the time.
Exactly.
Okay, then yeah, I make quick. I am quicker.
Sorry for the interruption.
Okay. Then yeah, thank you for your attention.
So your talk is over? Okay, thank you very much, Professor.
Yeah.
Your presentation is highly appreciated. You have questions in the audience, please. Okay. Okay, thank you very much, Professor.
Thank you.
You're welcome.